Hello everyone. In this video we are going to see about a common source stage with resistive load. So here we have an M1 transistor and then the load as an resistive. So here how we are calling this as an amplifier. When Vin is equal to 0, the M1 will be in off condition, so all the VD will be going to the output side. Once the V input crosses the 0.7 volt, for example, as a threshold voltage, the M1 turns on. Once M1 turns on, whatever it stores in the capacitor will start to get discharged through the M1. It comes to the output side. So here, as V in keeps increasing, so as long as the M1 is in saturation region, the output will keep on gets amplified. So we can ask a question that why need to have a 2 voltage source over here. This VGG is for unbiased voltage for the M1 to make it as in saturation condition for the M1 transistor. So here we have given an NMOS1 and NMOS. For NMOS1 we have made it model and threshold value is 0.7 volts, and with this 2 micrometer and length is 2 micrometer and lambda is 0.04 and then Kp is 550 micro and gamma is equal to 0. So at first let us do then an operating point condition. So at first I will disable the AC analysis. So here I have given bias voltage as 2 volts and then here I have given sine value as an sine input. DC offset is 0 and amplitude is 10 millivolts, frequency is 5 kHz. Since we are doing AC analysis, please give AC amplitude as a 1. So now let us do the operating point. So these are the operating point for the transistor. I can copy it. I have copied. I can give draft command text. I can paste it here. I can paste it here. So now let me do the trans first. By giving semicolon I have disabled it. So for transient so I have given trans and 10 milliseconds, top time 10 milliseconds. Let us execute. So the input is we can find here and we can find the output. It's an amplified output. Let me zoom it. So we can find the input is black one and then the blue is an amplified output. So the corresponding gain for the common source with resistive load is AB is equal to minus GMRD. So since it is minus, we can find the polarity is in the opposite side, it's a negative side. So there is minus GMRD. So the amplified output is in the opposite polarity, 190-degree phase shift has been happened over there. So this is the transient analysis. Now let us perform AC analysis. So in the AC analysis we can find a corresponding frequency over there. So at first let me disable it, enable the AC analysis. So what we have done is we are going to perform a decay analysis from start frequency of 1 GHz to maximum of 1 GHz if number of points per decade is 1000. So now let us execute. Let me execute once again. So now we can find, so here the 8 dB is the corresponding frequency analysis, and then the 180-degree phase shift has been happened. So and then if you have changed to a Cartesian, you can find the corresponding gain. It's around minus 2.7, the gain for this CS with resistive load. So now we can change the resistance. We have fixed the resistance as 39K. So if we have changed the resistance by different values, and then we can observe what is the corresponding gain in the output side. So for that you please open the parenthesis, give caps R and close the parenthesis. So here we are going to step this R is the number, name the parameter of speed, we can find here, and then natural space sweep is linear, and I'm going to start from 1k to a maximum of 100k with increment of 10k. So now let me execute. So here for different resistance values, these are the corresponding and gain. So to check, view, see step legend. Let me maximize. Yeah. So you can see here R is equal to 21k is blue, when R is equal to 21k, when R is equal to 31k, when R is equal to 41k, when R is equal to 51k, R is equal to 61k. As resistance gets keep on gets increases, so the corresponding gain, we can see how it gets modifies. So likewise we can change the width of your M1 also by means of step param W, and then you can see how much width you want to change from 1 to 10 micrometer, then the step value by increment value by 1 micro. Likewise you can see that you can sweep the W, and then you can check the output of your amplifier. So thank you for watching.